Here I want to talk about the exponential function. So the exponential function is given by this form, y equals f of x. What's that? This would be b to the x. So x is on the power. Okay, so here we have some requirements for this b. B is called the base. Okay, b is called the base. B is called the base of this exponential function. And here, there are some restrictions on this base b. B should be greater than 0, but b is not equal to 1. Okay, b is not equal to 1. So now let's look at the graph for the exponential function. So the graph for the exponential function have two cases. Case 1, when b is greater than 1. Okay, when b is greater than 1, then the function, the graph of this function is the increasing function, is an increasing function. That means as x approaches as x increases, the function values increase. So this is called increasing function. So this is the increasing function. Increasing function. And this is the y equals b to the x. And so this is the x-axis and this is the y-axis. And when x equals 0, b to the 0 is always equal to 1. So in other words, that the 0, 1 point is always on the graph. 0, 1 point. Okay, 0, 1 is the y-intercept, right? X equals 0, y equals 1. So this is the y-intercept. So this point is always on the graph. And here, this is the one thing. This is another one. Let's look at the continue. Let's look at another one. So here is the x-axis is the horizontal asymptote. Okay, the horizontal asymptote. So you can see that the curve will be very close to x but never touches x. Okay, x-axis. When x becomes smaller and smaller. And the domain from this one, the domain is all real numbers. In other words, you can plug in any number you want. The domain is all real numbers. So it's from negative infinity to positive infinity, right? All real numbers. All real numbers. Okay, all real numbers. And the range, which is the y values on the curve, right? The range, which is the y value on this curve. So you can see the y value on this curve, which is y greater than 0. Y cannot be 0, right? Because x-axis has the y equals 0, but this curve will never touch or cross the x-axis. So y is greater than 0. The range is y greater than 0. So in other words, from 0 to positive infinity. Okay, so this is for the first case. The second case is case 2, where b is greater than 0, less than 1, right? So b cannot be equal to 1, so we only have two cases, greater than 1 or less than 1, but greater than 0. For the second case, Let's look at the graph for the exponential function. This is the x-axis and this is the y-axis. So the graph will go down. Okay, so this is the y equals b to the x. So now let's look at some observations. The first one, like we did here, this is a decreasing function, right? It's a decreasing function. That means when x is increasing, the y values is decreasing. When x is increasing, the curve will go down, right? Second, when x equals 0, b to the 0, no matter what b is, always equal to 1. So in other words, this point is 0, 1 point. Third one, x-axis is also the axis is the horizontal asymptote. The fourth one, the domain is all real numbers. The range, which is the y values on the point, on the curve, which is the positive part of the y-axis, so it's always greater than 0. So it's y greater than 0. Right, so here that means i.e. is from 0 to positive infinity. Okay, so this is the two cases for the exponential function. Right. You can see almost the same for case 1 and case 2, except one curve is go upward, the other curve go downward, right? So now let's look at some properties or calculation rules, okay, for the exponential functions. Properties. So we have some exponent properties which says the first one, a to the x times a to the y. So here a should be greater than 0, but a is not equal to 1. So a to the x times a to the y is equal to a to the x plus y. You can put together, have one exponent, which is x plus y, if they have the same base a. This is the first property. The second property is a to the x over a to the y, which is equal to a to the x minus y. Right? The third one, if you have some a to the negative x, it's equal to 1 over a to the x. Right? Fourth, a to the x, then the whole thing to the y is equal to a to the x times y. The new exponent is just you multiply x and y. 5, a times b to the x is equal to a to the x times b to the x. 6, a divided by b to the x is equal to a to the x over b to the x. You can distribute the power exponent. Okay, 7 is used to solve some exponential equations. If you have a to the x equals a to the y, there is no other choice. The only choice is x must be equal to y. Okay. If x equals to y, then a to the x equals a to the y. If a to the x equals a to the y, then x must be equal to y. Number 8. So for x is not 0, then a to the x equals b to the x. If and only if there is no other choice, a must be equal to b. Okay? Then we can use these rules to solve some many problems. So here I want to introduce which is called a base e. So most case, so there is some special exponential function. Special exponential function. So we introduce a letter e. Okay, letter e is about 2.7. Okay, of course you have more decimals, but here I just say it's about 2.7. So there is a very special exponential function which is y equals e to the x. You can see this function in your most calculator. Okay, and this is e to the function. So since e is about 2.7, so it's greater than 1, so this function also have the graph looks like this one. Right? It also goes through the 0.01 point. So you will see this function a lot in many applications. Okay, and you should be able to use this function to calculate some numbers. Okay, so next we want to look at some examples.